Welcome back, guys. Let me solve now part 4 and part 5. Okay, let's begin with part 4. Find a specific item. We are still in problem 3 coding. So in order to find a specific item, suppose I have here node, I have here nodes, I have here nodes. So if I want to find a specific item, we know that suppose this is t. This is the route that I'm sending. So if t equal to null, return null. I couldn't find the node that contains the element. If not, I have 3 cases. Actually, the first case, that t slash value is greater than x. X is the element that I want to see if it's inside the tree or not. So if t slash value greater than x, what does it mean? Suppose x5 and here I have 10. So t slash value is 10. Greater than 5. I go to the left or to the right? You tell me. So if I have this condition, then I have to go to the left. Okay? Because x is less than. So return the function, suppose, is find, and I'm sending x and t slash left. Else if the same, t slash value, but this time is less than x. What does it mean? Instead of sending 5, I'm sending now, suppose, 15. So 15 greater than 10, yes, or 10 less than 15, yes. I go to the right. So return find, but this time I'm sending x with what? With t slash right. If it's not less than and it's not greater than and t is not null, so I have only one condition now, else that I have found the element, return what? T. Okay, so I cannot go left or go right. This means that I'm sending here 10, not 15, not 5. 10 is equal to 10. Okay, let's go back now to the coding. I have written the coding here just to save some time. Where is this? Is the function find. As you can see, it would return a pointer to a node. It will take x as a reference. This is the element that I'm going, the value that I'm going to search, and it take the root. And if t equal to null, return null. This is the first condition. The second condition, if x less than t slash element, this means go to the left. If x greater than let me see, if x greater than, go to the right, else return t. Okay, it's an easy thing. Let's go directly now to determine whether a binary search tree, determine whether a binary tree is a binary search tree. Okay, again, let me clear the window here, and suppose what I'm going to do, actually, suppose I have here 10, I have here 5, I have here 15. Okay, so is this a binary search tree? Yes. Why? Because as you can see, it's if any tree is null, if t equal, let us finish this case, is equal to null, then return true. Okay, so if I don't have a tree, then this a binary tree. Okay, now else if when I don't have when I can say that this is not a binary search tree, when instead of I have here suppose instead of I have 25 here instead of 5, it's not a binary search tree. Why? I search for this node. Suppose this node is 2 t. So t now slash left different from null. Okay, what does it mean t slash left? So I have if t slash left different from null. This means that I have a node here. This node exists. Okay, this is t, remember, and t slash left is this node. So t is exists. So t slash left different from null. The condition continues and end. So I have this value here, and if this value here is greater than this value here, this means that this is not a BST. Okay, you get it, guys? So how I can get this value here? This value here is t slash value. This is 10 and this is 25. So t slash value is 10. If 10, the value here, is less than this value here, so t slash value is less than t slash left slash value. What does it mean, t slash left? Go to the left of t. So I'm here now. Slash value, it means go inside this one, which is 25. So with this one here, this one here, all this one here is what is 25. So is 10 less than 25? Yes. When this condition is true, do you think we have a binary search tree? No, we don't have a binary search tree. As you can see, this condition is true. This means that we have here 10, for example, and here 25. So return what? Return false. Okay, guys? So if t slash left is different from null and t slash value is less than t slash left slash value, return false. We have the same case also. The same condition. I will write it here. Let me write it here. We have the same condition, and this condition says the following: if now, also else if. Okay, I will show it in the code. T slash right, the same thing. Different from null and end. What is the condition? T slash value greater than t slash right slash value, also return false. Okay, you get it, guys? So suppose this is 10, but instead of this 15, this is 5. Is this a BST? Suppose this is here, we have 4 and I have 5 here. Is this BST? No, because 10 should be what? Should be less than whatever on the right. Okay, this is the definition of the BST. Let's see the code. If this is not true and this is not true, then we call again the BST function, and we send 3 slash left and 3 slash right. Okay, so let's see the code because I want to save some time. I will write it down here. So what do you have? Boolean. Suppose the name is BST. Okay, and I will send binary node star t. Okay, and I will continue. As you can see, I'm writing the code now. If t equal to null, return true. Else if t slash left different from null, and end. What else? T slash left slash element greater than t slash element what should happen at this case? Return what? Return false. So guys, as I said, just to save time, I have implemented the function else if t slash left different from null and t slash left slash element greater than t slash element, return false. The same thing when it comes to the right side. So t slash right different from null and t slash right slash element is less than or equal t slash element, also return false. And if this is not the case and this is not the case, then go and test the other nodes. So go to the left and do the same thing, and go to the right and do the same thing. Okay. I'll see you in the next video.